Hello and welcome. Thank you for joining us for the 9th instalment of the Clough Expert Series podcast. Today, in honour of World Water Day, we're talking about the importance of industrial water, desalination and other water processes, and water projects in Australia. My name is Jillian Formentin. I'm your host and part of the engineering leadership team for Clough. Clough is one of Australia's leading engineering and construction companies and part of the Webuild group. The Expert Series podcast takes a deep dive into some of the exciting new projects and initiatives we're engaging in, and we feature special guests from across the business sharing their experiences and insights. And we want to use our industry experience and capabilities to help inform, inspire, and promote our industry and science, technology, engineering, and management. Together, we can build a sustainable future. World Water Day is an annual event on March the 22nd to raise awareness about the significance of fresh water and promote sustainable management of water resources. The aim is to address the global water crisis and support the Sustainable Development Goal number 6, water and sanitation for all. Efficient and sustainable water management can benefit individuals and communities in numerous ways, such as improving health and sanitation, ensuring food and energy security, providing protection from natural calamities, enabling education and employment opportunities, enhancing living standards, promoting economic development, and preserving various ecosystem services. Clough has been providing innovative solutions for water projects since 1963. Over the years, we've improved our design and construction capabilities to a world-class level. Our experienced team has a proven track record of delivering water and wastewater projects in both urban and remote regions. Today, I have the pleasure of introducing to the Expert Series podcast, Vijay Kumar, Deputy Chief Process Engineer at Clough. So Vijay is a leader in Clough's Energy and Resources Engineering team and has a deep experience in water engineering and projects. Vijay's got a first-class degree in process engineering and over 30 years' experience providing process engineering solutions from pre-feasibility to commissioning throughout Australia, Asia, and the Middle East. He's very collaborative and he believes in teamwork for successful execution of complex and challenging tasks, and we are very lucky to have Vijay at Clough. So, welcome to the podcast, Vijay. Thank you so much for accepting my invitation. I'm very excited to have this conversation with you and in honour of World Water Day. Would you please start by introducing yourself and telling us a bit about your role at Clough?
Thank you, Jillian. I'm really very excited at this moment. I joined Clough as a principal process engineer, and first task was assigned to me to be a focal point to Woodside. And I very successfully regained the confidence of Woodside that we are building a strong process team. And later I was given an additional opportunity to work as a deputy process engineer. And at the moment I'm building the process team, training the new graduates and junior engineers. And definitely this is mostly in the oil and gas. But I have a very wide experience working with the industries like ammonia and fertilizer, refinery sectors, where there is extensive use of this water, industrial water. And I can help in the strategy, Clough strategy to develop the water or enter into the water market.
Yeah, very good. And look, over 30 years, I mean, of course, I've seen your CV in detail. You've got some really exciting experience. And I'm interested today for our conversation about water to have a look at some of, well, what you know and what you can, we'll have a conversation about the opportunity of water. We mostly have a pretty good idea about the conventional use of water in the community. But how about industrial water? What's the importance of water in the industrial process?
So, industrial water definitely play a very vital role, especially in the production and manufacturing sector, where we need the water. Sometime in the processing stream, like ammonia, we need the steam for processing the feedstock to generate the hydrogen. Similar way, like other industry, like food industry, paper industry, they are very extensive use of water. So even in other industry like refinery and other downstream industry, they use water for cooling as well as wastewater treatment. So there are many use of this water is used for these industries, and we get the raw water from the water corporation or similar kind of from the river or desalinated water, but it needs further treatment in these downstream sectors to make it used for the process, like some of the process like steam generation you need very pure water, so that we need further treatment like ion exchange or some other technology. So that way definitely plays a very vital role, and I have extensive experience working with the downstream sector. So definitely we can move forward in the water sector.
Very good. Yeah, I guess we often forget about the different quality of water that's needed, not only that's needed for the actual process, but then, of course, there's the responsibility of making sure that the water that's going back into the environment is not damaging. And
yes, when we use this water and we are discharging to the sea, definitely it should meet the environmental regulation. So that's why we need a wastewater treatment. So we have the water treatment as well as the wastewater treatment. So both play a very vital role in the industrial water. And you will imagine that 20 to 20%, 22% of global water is used for this industrial.
20 to 22% of water used for industrial water. Wow, that's a big proportion, isn't it?
And it's really a vital for economy, country economy, and the production and prosperity.
Okay, very good. And you've seen all sorts of, because you've worked in so many different countries, Vijay, that you've seen.
Yes.
And does it change across country? Do you find different countries have got a different relationship to their water resources and how they can use it?
Yes, it's definitely changes from country to country, because everywhere, like if you see the India, we have vast resources of fresh water coming from the Himalayas via the river. But some other countries, they don't have the river. They are more dependent on the groundwater, on fresh water. And like in Australia, we have dams. So we are more dependent on the climate. So, and the climate is changing. So it has very big impact on the water industry in Western Australia.
I was in Africa a few years ago, and I remember the commentary about the way the water and the weather patterns were changing in the south of Africa is similar to what it is in the south of Australia, and it's just because of the way that the world's changing, and what's caused that, I guess, is open to some debate. But we do need to be able to move flexibly with the way that the climate changes.
Like Middle East, there is no any freshwater source. So mostly they are dependent on the desalination water.
Okay. Wow, that's interesting. All right, well, we've sort of begun to talk about this a bit, but optimising water use is obviously very, very important, and it's incredibly precious resource. So what can you tell us about optimising water use and maybe recycling as well?
Yes, optimizing the water use and recycling is really a very key factor, because you know that we have a limited resources of fresh water, and due to climate change, rainwater is going down. So, and we can't build many dams. So if you see, population is growing, and we are generating more wastewater, and that is going to be discharged to the either river or sea. So one way is, why not we treat this water good for uses rather than discharging to the sea? So that's the way of recycling the water. Like in ammonia plant, we are doing the recycling, like steam is generated, is produce the condensate, and we do some condensate treatment and we recycle back to the system. So that way we are um, we are optimizing the water makeup.
Oh, very good. So you're using the water as many different ways and as times as you can within the one industrial setting, so you can reserve that resource.
Yes. So we and other thing is we have to change our pattern of reusing the water. So that is also very vital, and that way we can optimize the water. If you need more water, definitely it will increase the demand on either on the dam. We don't have so much dam capacity, so we have to go for desalination, which is very highly energy intensive. So that's we should look at the sustainability of these water resources. So that way we are working on that part. That recycling is the very vital from that angle.
Very good. And Clough has got a long, long history of water projects, particularly in Western Australia. Since 1963, we've been part of the engineering water in Western Australia. Obviously, one of our important clients has been the Water Corporation, and we're currently engaged in the upgrade of the Woodman Point treatment facility, which is something that we're very proud of, and we're doing some good work there. And what can you tell us about this project, Vijay?
Yeah, this project is a part of the Woodman Point Water Resource Recovery Facility. So during the treatment of the wastewater, we generate some byproduct like biogas and the sludge. So biogas is already implemented. So now this is the second phase where we are implementing the 100% sludge recovery. So the sludge is very important part. The sludge will be recovered, and then that sludge will be dried via the high temperature and under pressure. So that way, and again that sludge can be fractured, and that can be utilized for the agriculture. That's why that process is called the thermal electrolysis process. So that's a good process. And Clough is having a alliance with the Jacobs and the Water Corp for that technology. But maybe in future, the Clough have independently handle that kind of technology, and we are very looking forward in that direction.
Very good. Well, what happens in a water resource recovery facility? Like, what can you share a bit about what the process is and how we treat wastewater before it's reused or discharged?
Yeah. So the recovery is basically whenever we are discharging water after use, we are discharging to the sea. Still, there are many constituents in the water which can be recovered. Like I said, the sludge, that is the one point of the Woodman Point. The similar way, there are some minerals which, when we fracture that minerals, it generates the biogas, mostly the methane. And that can be used for either power generation or heating because desalination is very energy intensive. There are different kind of desalination and like RO and other evaporating system where the steam is also being used. So we can generate the steam as well as the power generation. And I think the Woodman Point already implemented that biogas.
Yeah, that's a part. It certainly is an important part of the project, I think. They're very good. And then the project's using this THP process or thermohydrolysis process, and then this has been certainly part of the part of the project that Jacobs has brought to the Alliance. Do you know much about that, or is there anything you can tell us about how that process works?
Yeah, this process, like we recovered the 100% of the sludge, and that sludge has to be dried out. So during the drying process, we put under high temperature, 150 to 165 degrees centigrade, under a pressure of 7 bar. And this process is more like preparing meals using the steam.
We're cooking sludge, are we?
Yeah, cooking the sludge. So this improved that dryness of the cake, and then when it depressurizes, it fracture, and that can be used as a fertilizer because mostly it is a nitrogen and phosphorus, so which is very important for fertilizer.
So the sludge is treated, it's taken through this thermo process, it's fractured, then becomes available for, it's obviously a clean and hygienic process and used in our agriculture process.
Yeah,
so it's really a full cycle, isn't it?
Yeah, it can be used for fertilizer as well as reclaiming the land also. For that also can be used.
Right, and I'm excited too about the energy that comes out of the plant as well. So there's biogas. What can you tell us about that?
Yeah, this biogas is mostly a methane, and the methane that can be used for power generation as well as it can use for the heating purposes. The biogas is basically when we do the treatment, we put some enzymes in the water for treatment and which generate this biogas. And by recovering the methane, which is a very dangerous for our climate, so it's a similar, like it's more dangerous than the venting the CO2.
Oh, okay.
Yeah. So that way we are reducing the methane emission, and at the same time we are using that methane for generating the power. So it's a kind of renewable power, you can say.
Wow, that's really amazing when you put it all together. So we're treating wastewater that needs to be treated. We're creating fertilizer that's used in the farming and food production industry, and we're creating energy that can be used for all sorts of different energy requirements, but then also reducing greenhouse gases that could be damaging our environment. That's extraordinary, isn't it?
Yeah.
Really very good. Excellent. Well, we are very proud to be part of that project, and I love the way that this project is a collaboration between different companies to bring that important technology, design and construction into the West Australian industry here. That's very good. Well, let's have a bit of a talk about water projects generally. I mean, Australia, I think, has definitely been working together responsibly for a long time to deal with this very, very precious resource. In Western Australia, the water, the rainfall is somewhat unreliable, as you were saying before. And I think we are one of the driest places in the world, I think, in Western Australia, aren't we? So how important are these projects in Australia? And from your knowledge, what do you think is sort of coming down the track in terms of what we're going to need to deal with?
Yeah, definitely. It's what is the population is growing, and at the same time, there is a climate change. We have the less rainwater, so our dams are not filled with rainwater. So we have the shortage of fresh water for human beings. So definitely we have to look other alternative like more desalination plant. So like Watercorp already have 2 desalination plant, and there is another Alkimos. Alkimos also is, I think that site was identified for 3rd desalination plant. And if you look other prospect like hydrogen, there are many hydrogen plants are coming in future because solar power generation and renewable power. So you can imagine for 1 kg of hydrogen generation, you need 9 liters of water. So you need a huge quantity of water for this hydrogen generation. So definitely in coming days, we may have more desalination plant in those areas.
Okay.
Yeah.
Yes, because there's a lot of sunshine out there to harness.
Yes.
So water is an output from that process as well, isn't it? Okay. Really very good. And how important do you see skilled engineers? I mean, it sort of goes without saying, right? But let's have a bit of a talk about that too, because you are developing the Clough team of process engineers. How important is more new skilled engineers coming into industry to support the water requirements of the future?
Yeah, that's very interesting. So far, the Clough, we have engaged in the oil and gas, So if you look, we are also going into the power industry. So power industry is also very intensive for water treatment. If you look at the thermal power plants where we generate the steam for power generation. So from that perspective, definitely we are, because these are the young engineers, and you can mold in any direction, because the water industry is, if you look from the process engineering point of view, everybody thinks it's just a water, just pump it, send to the RO, and it will generate the pure water. But behind that, there is a very wide chemistry is involved. So that's why we are looking for some consultant who understand the water chemistry, and based on the quality of raw water, those consultant can decide what kind of treatment is required. So that is the water treatment, and other part is the wastewater treatment. So wastewater treatment is also very important, and because it's all recycling is depend on the wastewater treatment. And I think the Water Corp is looking by 2030, I think 30% they can do the recycling.
Okay, yeah, that's a it's a good target to have.
Good target, yeah. They have already set some target for recycling, so that we can minimize the wastage to the ocean or river. So I think this treated water can be used for for other purpose, for the golf course, irrigation. Even if you do further treatment, it can be used even for the power plant. And I don't know about the hydrogen, but because hydrogen needs more purer water, but it can be used even for industry, if we have like heating system, this water can be used, or even for cooling system, because cooling water also need a huge amount of cooling water for, like our ammonia plant is coming in Karnataka. So they use a huge quantity of cooling water, and after they discharge to the sea. But those are the seawater, so even if recycling is not much impact on the fresh water.
Yeah, very good. And we were talking earlier, Vijay, about the different types of water. We were talking about how much is surface water. I mean, you've worked in this industry for a long time, but what percentage of the Earth's water is surface water compared to groundwater? Like, what's the ratios we're dealing with?
Yeah, if you see, we have the wide ocean, and 97% is the salt water in the sea. So we have only 3% fresh water. Out of 3%, only 1% is available in groundwater and the dams. So even 2% is in the ice in Himalayas and Greenland. Yeah, so still we don't have much fresh water, and our population is growing. So it's how to best utilize this fresh water, and the only means is to go for recycling.
Right, so we have to desalinate, we need to recycle really responsibly, because 1%'s not much.
Yeah, because desalination is one way, but it's very energy intensive. Like in some other countries, like in Israel and other things, they have other technology, like they are absorbing water from the atmosphere. Right. It's a very little quantity, but they have some technology.
Yeah, very good. Yeah, because we're not using that much in Australia, because we've got other. I guess we've got maybe cheaper alternatives.
Yeah, that could be one challenging, and that also is a cheaper option, and it's good. Is a good drinking water quality.
Very good. And the world water issues are, there's a lot talked about water. I think one of the things that I'm excited about for the future of these issues is the collaboration between different organisations to bring all the different thinking and engineering to solving those issues. I think that's one of the opportunities we have in Western Australia, and certainly how Clough's positioned is to partner really strongly with the different contributors. It's definitely a team sport, isn't it? Some of these big intractable issues, and I think water and the treatment of water and the treatment of that precious resource. It's a collaboration, isn't it, between Water Corporation and Jacobs and Clough, not that for Woodman Point, but then all the other different players in the industry.
Yeah, because even I think Western Australia, if you look, only 50% water is coming from ground or the rainwater. Still 50% is from desalination.
Yeah, I think it's not a well-known fact. We kind of think, like we're looking out our window here at the at QV1 where we're doing this recording, you can see a beautiful river and, you think, what's the problem? But it's actually a really, really precious resource, isn't it?
Yes. And Australia, still population is not very high, but if you look from worldwide population, many people are not having good quality of drinking and sanitary water.
Yeah, because you've lived and worked in way more populous areas than Western Australia. So, throughout Asia and the Middle East, what are the most lived and obviously lived differences in some, between here and some of the other places you've been when it comes to water availability?
Yeah, definitely is like in coming years, the water crisis will be a big challenge.
Yeah.
And like in India, if you see, the most of the groundwater is used for agriculture.
For agriculture, yeah.
Almost 65% groundwater is used for agriculture purpose. But because it's either it is dependent on the groundwater or the rainwater. So there is no any other solution. Either they go for some new technology for diverting the river water for the agriculture. So that's another technology is required, or more sustainable approach to be developed for that. But every country has their own problem. Yeah, it's not that what solution is in Australia is applies to worldwide. Mm-hmm. So every country, we have to deal with the local constraint and whatever the resources available. Accordingly, we have to plan. Everywhere the concept should be how to optimize and recycle.
How to optimise and recycle. Okay, I think that's a really strong message. Yeah, we are very lucky in Australia where mostly we don't need to deal so much with waterborne diseases, like in some parts of the world that you have been and worked. I'm sure that was more of an issue than it is. I mean, it's certainly something that is also to be protected against.
Yeah.
That optimise and recycle.
Yeah.
Okay.
Like even I've seen in Victoria. I lived there for 2 years. So if you compare the water use in Victoria and Melbourne, Western Australia, definitely still Western Australia is very lucky compared to Victoria,
Yeah.
where there is a ban for water during the hot season. And another is bushfire. Bushfire also requires a huge quantity of water. That's also is another challenge.
So yeah, this is such an interesting conversation, Vijay, and we're running out of time. Just have a thought about now that Clough are part of the Webuild group, which is a really exciting and much more globally focused company. I think there's an opportunity for Australia to even bring some of our water solutions to the world. How do you think Australia could be part of the picture for helping the world deal with some of the water quality and shortage issues?
Yeah, like the Webuild is already have many water projects like Snowy. Snowy is also one of the we are utilizing the water for generating the renewable power. And similar way, we have some expertise available in Italy who has worked on our mega water treatment plant and wastewater treatment plant. First thing is Webuild is already working across the world in Italy and Middle East and North America. And there we will have good presence and we have the technology available, and that can be utilized worldwide. But the message is very clear. We are looking for sustainability in the water resources. That is very clear message from the Webuild.
Very good. And it's exciting to be part of that partnership now, to be able to bring our expertise, like it's a limitless opportunities for being part of the solving of those problems worldwide. Vijay, thank you so much.
Thank you.
It's very, very interesting to talk to you and to just discuss your perspective as a very senior process engineer for solving these important issues. So thank you so much for joining me today for this conversation. You've been listening to the 9th episode of the Clough Expert Series podcast, where we've been talking to Vijay Kumar as one of our very special experts as part of the Clough group, now part of the wider Webuild group worldwide. So thank you very much. And we look forward to bringing further topics to this platform over the coming weeks and months. So thank you, Vijay, for joining us today.
Thank you, Jillian. Yeah.